Let's get right into it. Make sure to download the basic shapes folder with the 3 basic shapes, circle, square, and triangle from the GitHub link in the description. How do you create one? Very easy. Right click, Effects, Particle System, Essential, zero out all these numbers. It should be at 0, 0, 0 position and 0, 0, 0 rotation. Next, let's make a texture onto these particles. Let's put a sprite onto these particles. Very easy. Scroll down to Texture Sheet Animation, check the box, open up the tab, select Grid, change it to Sprites, click this small dot. It will open up this panel, and from here you can pick anything you want: circle, square, triangle, and they will all change the sprites. For now, I'm going to open up square because it demonstrates things like rotation. Next, what I'm going to do is I'm going to show you what these different properties do. Duration is how long the particle system goes before looping. You can uncheck looping, and if you put duration at 0.1, they'll all disappear. Now observe if you restart. For example, duration 1, if you restart for 1 second, particles will emit and then it will stop. Next, start delay is how delayed it is before it starts. I'm going to put this at 1 and put duration at 3. After 1 second, these appear. Very nice. I'm going to put this at 0 for example reasons, and this keep at 3. Start lifetime and start speed are very fun. Start lifetime is how long the particle will last. For example, if I put 1 and I restart, this will make the particles last less. Now, this is where variety comes into play. Particles are something you look at over and over constantly in a game, so you want to go ahead and click this button right here, and you'll see these: constant, curve, random between 2 constants, and random between 2 curves. The most essential one you need to know for this is random between 2 constants. If you place random between 2 constants and you make this number its initial and this number greater than the initial one, you'll get a random. For example, if I put 1 and 3, you'll obviously see some particles that last longer than the others, like these ones versus these that immediately disappear. This is excellent for adding variety to your game, but make sure you don't have something that is widespread like 1 and 10, where you will have some particles that disappear right away versus some other particles that last incredibly long. I'm going to keep this between 1 and 2. Start speed is very useful. Start speed allows you to change what speed the particle goes at by the start. I will also change this to random between 2 constants and put it between 10 and 12 just to demonstrate. As you can see, some particles are going faster than other particles as they emit. I would recommend not checking 3D start size for 2D games, which is what this tutorial is mainly for, but it can be applied to 3D concepts. Start size is also very useful to check random between 2 constants. I'm going to put this at 0.5 and 0.8, and you're going to see how there's variation between the sizes of the particles. Start rotation is one of the most essential particle settings you can ever have, because if you put this random between 2 constants and between 0 and 360, which is maximum rotation, you get a very large variety of different rotations in your particles, and it looks better. Next, I'm going to talk to you about start color. If you change the start color, it will change what color the particles emit at beginning. This can be overridden by settings down here, so make sure that you're not messing with settings down here if you want a flat color. For now, I'm going to keep the colors of the particles a purplish. This looks kind of strange, so I can go ahead and go in and change it to more of a green color. This is super easy to change. You can also have random between two colors, gradient, random between two gradients, and random color. Random color allows you to edit gradients, but that's a bit too complicated, so let's keep it between random between two colors. If we change it to a similar green, but it's darker, it's going to get some interesting results. These do look varied, which is nice. Observe that if you put it at something like red, you're going to get drastically different colors, and they look blended in. So make sure you have two similarly looking colors. I'm going to keep it like this. Gravity modifier, usually you want to keep this not at random between two constants to have a consistent gravity. I'm going to put this at 1, and you're going to see that particles will go downward. Remember, speed and gravity actually interact with each other. So for example, if you have a particle that launches upwards, it will go downwards if the gravity is greater than 1 at one point. If the gravity is negative, particles will start falling upwards. This can lead to some interesting particle systems. I'm going to keep gravity at 1. Next is simulation space. Simulation space is a pretty interesting toggle. Keep it between local and world. If the simulation space is local and I restart this, I'm going to first make it last looping so that this constantly falls. Local means that if I move the particle system, particles will move along with the system, and they will move relative to the transform of the parent object, which is this. I'm going to re-put this at 0. Now, here's where it gets interesting. If you put the simulation space at world and you move the particle system around, particles won't follow the system after they've spawned in. So this is excellent for some particle trails, or maybe you have footsteps that bring out dirt. You want this to be relative to the world. I'm going to keep this at world. Placing it back at 0, 0, let's talk about simulation speed. If you make a faster simulation speed, the simulation will run faster. It may be a bit redundant, but you can see how this goes. If I put the simulation speed slow, it will run slower. And it can only be 0 at its lowest. If you put it incredibly fast, it'll do something like this. I'm going to keep this at 1. Scaling mode and delta time I will not cover, but I will cover play on awake. All play on awake checks is that it will play when it first exists in the scene. This is for stuff like if you immediately want it to play after instantiation, you definitely do that. But there's a function called play along the lines of play that plays the particle system, so you can actually do more code-centered particle systems with that. I'm going to recheck this. I'm not going to go over any more parameters below play on awake. This is just for simplicity's sake, and for my personal growth, because I do not know exactly what these do. I'm going to now go over emission. Emission is really interesting because you can change rate over time and rate over distance. Rate over time is the more interesting one in my opinion because it allows you to have more particles spawn in or less particles spawn in. For example, if you have an extremely high one, you will spawn a lot of particles, while if you have something like 10, you'll spawn in not as many. To demonstrate rate over distance, I've set rate over time to 0 and rate over distance to 10. Next, I'm going to move the object. As you can see, as the object moves, particles will spawn. This is very interesting to play around with if you have something like a flying particle, where you have an object flying around and you want particles to only spawn when they're flying. This makes it so that if you move fast, a lot of particles spawn in the area, but if you move slow, it's very varied. Something like 1 will result in a moderate amount of particles. I'm going to keep rate over distance at 0 and rate over time at 20. The other interesting thing, after I zero this out, is bursts. Bursts are very good for things like explosions. Let's add one burst in. As you can see, as it loops, it's going to burst. If I restart, it's always going to burst at the beginning. There's a few different parameters. Time, this won't burst right at the beginning. It'll burst 1 second after. Count, I can put 100, so when it bursts with a lot of particles, keeping it at 20, 30. Cycles, if I change this to 2, you can see that it cycles. Let's put this at 10 for a greater number. As you can see, at 10, it looks greater. There are more particles. The interval and the probability. Probability is something like 0.5 as like a percentage. As you can see, the burst will occur, but if you wait, the burst seems to only occur half of the times that it's supposed to. So let's keep this at 1.00. Remember, this should be between 1 and 0, because that's what a percentage is. 0% probability obviously means never, 50 means half the time, 0.5 means half the time, and 1 means the entire time. Let's change interval to about 10 and restart. Interval seems to do little to nothing, but if you check, repeat the burst every n seconds, it just means the burst will repeat after X amount of seconds. I'm going to keep this at its original 0.010. The particle system explains a lot, so you make sure to hover over these. Shape. Shape is very interesting. It's in what shape your particle will actually emit. And this is where these positions come into play. Remember how we always zero the rotation out? That's because this is the rotation of how the particles emit. So if you're going to edit rotation, do not edit it up here, edit it right here. For example, if I rotate this cone downwards, you can see that the particles are emitting downwards. Let's change this to 90 degrees. I'm going to go into 3D view, and you can see that this cone is actually three-dimensional. We can change its Y rotation, its Z rotation, and its X rotation. I'm going to reset it to 0, 0, 0, and it's supposedly pointing forward, but I'm going to change back to 2D. Perfect. Cone can be swapped out for a lot of different ones, like sphere, and let's view these all in 3D. Sphere, hemisphere, which is half a sphere, cone, which is what we had, donut, which has a hollow inside and allows for some interesting particle systems, box, which usually shoots out one end, mesh, which is you have to apply a mesh to it, mesh renderer, skinned mesh renderer, sprite, sprite renderer. Now these are all specifically assigned right here, and I'm not going to go over that. But circle is very interesting, edge is very interesting, and rectangle is interesting, because we are working in 2D. I'm going to set this to circle so it bursts outward. This looks so much better. You can edit the radius usually, the thickness of the radius, how much it arcs, so you can make it only go, say, above. I'm going to set these to 180, 0.5, and 4. Perfect. mode random, loop, ping pong, and burst spread. These are kind of interesting. You can loop it around so it looks like it's doing that. Ping pong pings-pongs it back and forth. Burst spread, it just spreads this burst. It's not very interesting. I like ping pong, loop, and random. I prefer random best of all. But ping pong and loop can be interesting. You can change the spread, and apparently, if I put the spread at 1, it'll only go there. So, I'll keep it at 0. This spawns particles only at specific angles around the arc, apparently, so you can say at 45, at 180, at 6. Since the arc is limited, I think that's the reason it's looking strange. 0 spread for now. Remember, you can change the rotation, but remember to not change it in the 3D zone. You usually want to keep it at Z, which is rotating it around like this. Position can change its position relative to the object. I won't recommend doing this at all, but scale can. This is simply the scale. If we put it at 10, 10, 10, you can see that the particles don't change their size. It's simply the size of the where it's emitting from. Next, checking a line to direction still spawns them. You can see these little tiny oranges, but it seems to kind of corrupt them in a way. And the reason it looks corrupted is because it's aligning the particles to the direction that they're flying out of. So you can see that the particles are facing the way that they're emitted out of, which you can see in 3D and it looks amazing, but in 2 dimensions you want to keep it at this billboard format. You can randomize their direction, spherize their direction, and randomize their position, which all adds some more variation, but I prefer to keep this at 0, 0, 0. This may be a bit interesting at randomizing the direction, but it allows particles to sometimes go through that, such as that. Let's go velocity over lifetime. This is where curves come in. Curves can be accessed by swiping up right here. You can also edit these. There's no change apparently now because this is probably this is velocity, right? So it's going to velocity over lifetime is a bit more advanced, so let's skim over that. Inherent velocity is interesting, but I'm still not going to go over that. It has to do with spawning particles on death, and that can be kind of interesting for things like rain, but I'm not going to explain it in this tutorial. Now, manageable ones are color over lifetime. You can change the color of the particle over its lifetime. For example, it can become redder the later into its life it is, or bluer. This is an additive color, remember. So it will retain the original sprite color, like green, and it will shift its hue over to red. I'm going to keep it like this. Color by speed allows you to have different colors according to how fast it is going. I'm not going to enable this here, but you can change the range of the speed and how different the color is. For example, you can see that how the purple changes depending on how fast it is going. You can see that it slowly starts to go darker and darker as it goes faster with the gravity. Of course, I'm going to uncheck color by speed because this is not needed right now. Size over lifetime is a lifesaver. This is where the curve is used and you should learn it. This, imagine it as a graph. You've done graphs in school, right? Basically, if you want, for example, for the particle to start at 1 and then end at 0 as a curve, you want to do something like this. It starts at 1 and slowly goes over time, becoming smaller and smaller until it disappears, not abruptly disappearing. It looks so much better. If you double click, you can create these nodes where you can edit the sizes and make them bounce around, for example. Boing, boing. See how they're boing, boing? They're becoming bigger and smaller. For now, I'm going to delete these points and just keep it at this nice steady curve downward to 0. This makes it look so much better. Size by speed is similar to color by speed. It changes its size based on its current speed. These overlap with size over lifetime and color over lifetime, remember, but I'm going to keep it simpler in this tutorial. Rotation over lifetime can change what its rotation is over lifetime. Checking separate axes is usually for 3 dimensions, so I'm going to keep it like this. If I put this at 180, you can see that particles go out and they spin as they die. Die is a weird word, as they finish their life. Rotation by speed is similar to size and color by speed. Its rotation is affected by how fast it's going. Noise is very interesting. It allows you to add, for example, one of these noise black and white pictures to your particles. You can make it more frequent or you can make it greater. But here's where it goes. You can make it scroll to make it vary between almost every time, have different octaves, but the strength is the thing that really affects it. If I bump up the strength, you can see that these are flying around. You can get some really nice effects like lava bubbles or wind scatter particles by just doing something like this. You usually want to tone it down though to 1 so it's very subtle. I'm going to keep it like this. I'm going to scroll down. I'm going to put this system curves like this, and bam. The last thing I'm going to go over are trails. As you can see, the trails look very ugly right now. And trails are very similar to the trails in the editor, and they will just trail after your particles. This orange triangle says assign a trail material in the renderer module, and you can actually assign one right here. I'm going to pick a trail, but there's none, so I'm going to pick default line. Now it looks better, and it's going to be the same color as the particle. You can change some parameters like lifetime, so it follows after. If you set it as 0.1, it'll follow the particle after it. You can have its ratio, which is how many particles will actually have that. You can make them world space, so if I move the particles around, they will actually move along with the particles as well. That's very nice to have everything in world space. 0, 0. Again, you can have color over lifetime and color over trail, which is, it says select a color for the trail from its start to end vertex. These are overriding them, so I'm going to put this at white. Color over lifetime just makes it orange right here, but I would think that it would be better as a gradient, where you could set it to something like purple at the end, so the trail becomes more and more purple as it goes. For this current particle system, it isn't looking as good, so I'm going to uncheck trails. The final thing I'm going to go over, which I skimmed over very fast, was collision. For this, I'm going to simply right-click 2D object, Sprite. I'm going to zero it out, place it down here, add a box collider 2D to it, and make it Sprite, the square Sprite. I'm going to resize it, put it at 0, 0, move it down, and then there we go. We have a floor. I'm going to make this a longer floor, and it also has a collider. I'm going to reset the collider so it resizes automatically to the size of the floor. This isn't part of the tutorial. This is just creating a floor. Maybe you want to slow down the video and create one yourself. I'm going to move this particle system down a bit, and next I'm going to check collision. Of course, you won't see the collision happening immediately. That's because you want to select from planes to world. It still won't collide, so make sure to check the mode to be 2D. Now you can see that particles actually collide with the floor. You can dampen the speed as it hits the floor, make it bounce more. As you can see, it's bouncing a lot. You can make it lose its lifetime on collision, which makes it die immediately on collision. And these other parameters I won't go over except for collides with. This allows you to change the collider mask of what it collides with, which is very interesting. There's also collision force, but I won't go over that. In the end of the day, I'm going to change the gravity modifier to be around 10. So you have this nice looking green. I'm going to change this floor to a nice green, the camera background to a darker green, and then we can see what this tutorial has resulted in. If we hit play, you can see this very nice particle system. It rotates over its lifetime, has bursts, and it's in an arc generating. If you've got any comments or questions, just make sure to ask. The particle system has many tiers of challenge and difficulty. I will say that this tutorial goes over the basics to get some nice understanding of how everything works. And remember, you can find all the shape downloads and this exact project to download in the description as a GitHub repository. You know, have fun with your particles, and, you know, it's all good. You know what they say? Unity's particle system is the best particle system.